Everyone, thank you for coming. Before we get started here, there was a time change earlier today. There was a prior speaker here at this slot who was not able to make it, so I have been moved to take in this slot. We are talking about building multi-tenant compute systems in the enterprise. If you think you are here for something else, you are in the wrong spot. I'm Zach. I lead model and developer platforms for CapitalOne. I have kind of an interesting background. I've been an individual contributor, a core engineer, data scientist, and now I am leading teams to help a large financial institution build out capabilities and platforms to allow their data scientists and engineers to do their job better, faster, stronger, all the things that Daft Punk will clap me with a copyright infringement for. I have been at CapitalOne for a little time. I am still there now. Previously, I was at startups and I did all sorts of fun and interesting things with doing large modeling. I'm happy to talk about time like that. We will have a little time at the end if for some reason you want to ask any difficult questions about DNS or reverse engineering. I will warn you as we get started that I have a sense of humor. You may regret this, and I encourage audience participation, which I may end up regretting. If you take nothing else away from this talk, enterprises are rarely monoliths. As you begin to build material within them, you will find an interesting tableau of different requirements, speeds, needs, regulatory considerations, and constraints that you are going to have to build around. Consistency and standardization is very hard, but without it, you are leaving serious value on the floor. And then finally, you should have a plan for wild success. One of the things that I have found, especially transitioning from startups into larger enterprises, is the fact that teams will go out and they will build something, and then people will come and they will use it. And then those teams begin to realize very quickly that they are not prepared for that scale. And the reason they are not prepared for that scale has nothing to do with the size of their instances or the speed of their application or anything along those lines. And it has things to do with stuff like multi-tenancy and how you handle security considerations and how you manage your controls. And so this talk today is about those things. It is a talk today about building platforms in an enterprise, hitting on something that is meaningful and required, achieving wild success, and then coming to a full realization of why success can sometimes be challenging. The last thing that I will say is that I have 50 slides to go through and about 20 minutes and to do it, and so let's get started. I've given 83 presentations in my career, and 83 is the number of times someone turns around and tries to tell me a story, or tells me to tell people a story. And so we are going to do that. We will do that through the narrative device of a 3-act play. Here's our introduction. Our world is pretty exciting. I think that if you go to any other of the talks in here today, you're going to hear people talking about all sorts of fun stuff. And if you, for some reason, are gracing the vendor's floor, you are going to see lots of people talking about generative AI. Generative AI as a field is less than 2 years old, and for all practical intents and purposes was inaccessible until about 8 months ago. It is fascinating how quickly startups can get going, but it is a fun and exciting space right now. I am not a big fan of excitement. I am a big fan of emphasis boxes. You will see them again. Why don't I believe in excitement? In fact, why don't most large enterprises believe in excitement? And it's for one reason. If you hire someone to renovate your kitchen and they show up in one of these vehicles, you will think nothing of it. You are going to get a new kitchen. And it will probably come in approximately on time and approximately on budget with relatively few surprises unless you, like me, live in a very old house. If, however, your general contractor shows up in this, or God forbid one of these, the tone of the next few weeks will shift dramatically. Boring things usually just work. And that's the general statement that I like to give here. When you have something that just works, you forget about it. You're doing stuff with it. It becomes boring because it's enabling you to do the things you need to do. And as I may have hinted slightly at the beginning of this talk, that is what we're here to talk about today, the boring things that people usually end up forgetting about. One of the things that you might be asking yourself is, where are we going from here? You've suddenly gone on this strange diatribe about something you don't like. Where is that leading us? And that brings us, going back to our narrative device, to Act 1. Let's start at the beginning, which, according to The Sound of Music, is a very good place to start. Enterprises are not monocultures. Enterprises are things that grow organically. Even if you are part of a firm that has grown rapidly and quickly and without acquisition, you're going to find yourself in an environment that has attempted, if not hopefully succeeded, in starting up multiple different revenue streams. You have multiple stakeholders, you have executives who have their own particular way of seeing the world. If you work at an enterprise somewhat similar to mine, that being CapitalOne, you're going to have fundamentally different lines of business, right? Our credit business is fundamentally different than our consumer banking business. They have similar concerns, they work to similar ends, but at the end of the day, you treat those products fundamentally differently. And that is seen in almost every single aspect of the business as a whole. One of the things that I think is very important inside of organizations like this, especially ones that have grown organically, is that you start to develop a group of haves and have-nots. Older, more profitable, more successful sections of that business tend to become entrenched, and they have a very easy time bringing in large amounts of money, attracting talent. Even if it's not a money issue, they have more reps behind them. They spend more time, they have thought about problems a little bit more deeply, or just have more time behind them. And so you begin to get this very different environment, where different groups inside of the company, even if they're all aligned and working together, begin to get different views on how they tackle their problems, and they have different kinds of bench strength that sit behind them. One would suggest that about 5-10 years ago, probably the most important event in data science happened. The Jupyter Notebook was created. The Jupyter Notebook is a critical thing inside of modern data science for one reason. It made a lot of things more accessible. And accessibility, especially in a large company where you have people of varying different skill levels, of personal interests, of experience that they have behind them, having things be more accessible to them is critical for adoption and movement. And so Jupyter Notebooks exploded in the industry through enterprises at large. They became kind of the lingua franca of being able to turn around and work in this. Anyone who wishes to criticize my Latin pronunciation, you may do so at a later time. At the end of the day, Jupyter Notebooks were critical for all of us because it allowed these organizations that had haves and have-nots, more engineering capabilities, more machine learning, more statistical capabilities, or less in some cases, to all at least meet each other in a common ground of how they did their work. That being said, Jupyter Notebooks, having been adopted so aggressively, has made a lot of people angry and is widely considered as being a bad move. My apologies to Douglas Adams. Naturally, teams responded to this. In any enterprise where you go into, one of the things that I have found is that you see this common evolutionary pattern. You have a team that start doing data science and machine learning. They start inside of Jupyter Notebooks. They realize that there are scaling and limitations to those Jupyter Notebooks, ranging everywhere from the hard compute challenges to things like how do you manage that code base? How do you have controls built over it? How do you ensure that you don't have 13 different kinds of mutable state in the middle of an execution of a notebook, and how do you productionalize this? Teams meet this challenge. They have become successful. They start to grow. What got them to a period of success will not get them to the next level of success, and so they begin to stand up their own infrastructure. In general, teams inside of these environments coordinate in no way whatsoever. Before anyone gets ahead of me, please don't turn around and say, oh my God, CapitalOne teams aren't integrating. I'm talking very generally here. This is a challenge that you have when trying to coordinate large groups of individuals with disparate and many individual incentives. Teams want to accomplish their particular body of work. They stand up their own environments, and so you start getting this kind of necessary duplication of infrastructure and capabilities. Many things are trying to do the thing, but they're doing it differently, and then silos appear. One of the things that CapitalOne did to tackle a challenge like this was, as we started to have this experience, we began to merge these platforms together, constructing this model of a model platform environment overall, effectively breaking it down into a couple of different areas. Model construction needs a body of infrastructure, validation and soft deployment needs infrastructure, promotion into production, and monitoring and refit. All of this together forms a relatively composable architecture that is pluggable. You're able to take individual components of it and swap it in and out relatively easily. The other thing that I think that at CapitalOne, at the very least, we did, is we began to centralize these capabilities internally. Instead of having a world where every single team built their own body of infrastructure, we began to centralize this infrastructure. This created a couple of opportunities for us, right? We figured that we would turn around and be able to have a world where everyone's working in the same operating environment. Everyone is largely using the same tools. And most importantly, everyone has a similar workflow, right? By and large, these things did in fact happen. However, when we built this for the first time and launched it, challenges quickly became apparent. Act 2, 3 is a crowd. Coordination in large organizations is very, very hard. There's a couple of reasons for this, and it's mostly due to the fact that it takes time for signals to propagate in a large organization. There's a lot of different ways that teams build models. When we started building our model platform a few years ago, one of the things I think we had the internal assumption was that most teams did this in the same way. Nothing really could be further from the truth. There are some teams that like DM Crisp, for example, and there's a couple of other teams that like lighter weight frameworks. Quite frankly, I've never found a single group that does it all the same. Even on just individual data science to data scientist level, from team to team level, everyone has individual changes that they make to bring it into the mix. Sometimes there's really great reasons for this. You might work in a regulated industry, and there's steps that need to be added to make sure that you're doing the right thing and you're doing it in the right way. In other cases, you might be in a situation where data scientists just simply come from a particular school of thought, and so they do things in their own unique pattern. One of the first things that we started to do after kind of realizing the propagation of these different ways of doing things was heavily adopting into the MLOps framework. Our policy here was to start from a position where we standardized how these users did their work. Our principle was the actual act of doing the work is something that a user is going to do multiple dozens or hundreds of times a day. That's an inner flywheel that kind of drives all of the other behaviors. If you build the framework around your operating environment, around that flywheel, around that workflow, you're going to have an environment that will at least be low friction for your individual users. And so we adopted this really quickly. The other thing that we did, as we created that larger body of workflow-based standards, was we created secondary standards and processes that helped us mitigate some of our communication issues. Things like breaking down communications between teams and turning those from personal discussions into technical ones, creating hard-lined SDKs and library standards, making sure we had consistent artifacts, and leveraging tools like gRPC or Thrift or any of the other standards of communication that are available out there that leverage code generation to ensure that we could publish one RPC standard and allow teams to be able to easily create their own clients and their own services that we always knew would be compliant with this particular standard. This increased our overall flexibility and let us find new and interesting ways to be able to adapt to changes that we saw. This technical contract part is something that we're particularly passionate about. If you rely on humans and relationships and human-based communication across large systems, that can be necessary at times, but it's rarely sufficient. And having these defined interfaces allowed us to become very resilient to change. When something began to change or shift, or if the team such as mine needed to alter the back end of the larger model platform, we were able to find ourselves in a position where those changes could be done more or less seamlessly. We didn't have to worry about breaking clients 95% of the time. We were able to ensure that our standards were both backwards compatible and clearly could bring the clients along with us in most cases. Between that MLOps, we were able to standardize the overall space internally. And that standardization was something that allowed us to constrain the design problems and ensure that we were in an environment where there were a limitation of things that we needed to be able to directly support. We've talked about our stack before. You may have seen other CapitalOne talks here today or another talk that we've given in the past. But the general principle here is to attempt to move as much of the company as possible into an environment that is, one, both sufficiently modern and both sufficiently well supported to ensure that both new users coming into the company, effectively new data scientists that we're hiring, are coming in with a general purpose understanding of the work that they are able to do, as well as the environment they're able to do it in. So great, MLOps, centralized infrastructure, and well-respected frameworks. This sounds like an open source and standard success story. However, as you have probably noticed in the theme of this presentation so far, more trouble began brewing. We were successful in the beginning. We realized we moved to a new position and had different challenges. And then here again, we were successful a second time, having grown to that new state, and yet again find new things. Remember what I said about boring things previously? I've stolen this from XKCD. Everyone should appreciate XKCD because there's something of truth in every single one of those. But ultimately, everyone wants to do some exciting things. And I would say that you see this a lot inside of open source. You see tons of volunteers coming into open source to work on things that are exciting. And that's great. Volunteers aren't paid. They're working on this stuff for personal satisfaction. And so you end up having people who think really deeply about performance, algorithms, protocols in their communication, features, especially comparative ones. And you start getting into the situation where people think so deeply about the things people get excited about and write talks about. And that's great. However, things that don't get thought about in the open source world nearly as much, or inside of companies when small, scrappy teams start building things and becoming successful, the first thing you think about when you're 5 people is not, how do we create a multi-tenant environment? What are all the deep security considerations around identity and access management? And how do we manage our data at a tall step? And as you start growing, you start realizing you have needs and concerns you didn't think of before. And this isn't a criticism. It might be impossible to make those 3 things enterprise ready for general purpose open source software, or really in a composable pattern that works between different environments. Every enterprise handles these things in different ways, both from a technical level and a business constraint level. And so we keep finding ourselves in this position where the thing people get excited about, and the things that my users get excited about, the data scientists and the MLEs, they want to care about that black box in the center, that ML core, the core aspects of their modeling opportunity. And then you end up in a world where you have to, if you're building your own infrastructure, and it's different for every single team, they have to think about everything else around it. And so our policy here was to make sure that we thought about all of those other things from a platform perspective, so that our users could only think about that dot in the center. Large distributed systems have unique security challenges. There's a whole different things here, a whole body of different material here. For example, what if tenant 4 in this diagram is for some reason able to access the Kubernetes namespaces of other tenants? What if they were able to leverage a disproportionate number of compute resources, or access data or confidential information from other namespaces? Now imagine it's not 4 tenants, it's n, arbitrarily large, more people coming in every day, and then you have more complicated situations where you have subgroups of these users who need to be able to access everyone else's data, for example, an audit organization or a security organization, or you have other subgroups of users who only need to access a subset of that data. We call those teams. Security considerations can't come last. Multi-tenancy is ultimately not a feature of your platform or capability. It is a baseline security expectation. And so you need to make sure that you're building all this material in the same way that teams will talk about MLOps considerations for deployment. You want to also make sure that you're thinking about tenancy and security as a core piece of functionality, and you build it in from the start. Even if your teams are building something brand new and your teams are relatively small, you might not be able to build everything you want at day one, but you can make sure that you have the hooks, the leverage, the capabilities, the areas where you can continuously add and modify this material based on when it's necessary and it's present. Things like data privacy, cluster and resource management, and a seamless user experience are all things you need to be thinking about, because you want to make sure that you have that accessibility and you're able to ensure that your users don't have to think about these considerations in their day-to-day activities. This is ultimately what this can look like. One of the things that we've looked at right now are Zanzibar-based systems, so that's something that we're very concerned about. One of the neat things inside of a Zanzibar-based system or more modern IAM capabilities is you get this ability to extremely fine-grained permissions. Instead of working purely inside of an environment like LDAP, which allows you to have coarse-grained permissioning, you can get permissioning all the way down to row and cell level if perfectly necessary, and it becomes an overall part of your larger backbone that your platform and other platforms can leverage. Scaled entitlement management enables an entirely new way of thinking about permissions, which is pretty beast. Entitlements, I said before, are for more and pure access. They're more than just that. They can also support things like feature flags and sub-offerings. Building in these capabilities from day one, these non-functional requirements, allows you to reimagine the way that you leverage them. And that's probably one of the bigger lessons that we have learned. You can also use things like centralized entitlement capabilities to help manage resource assignment and usage. You ultimately start finding yourself in a position where there's a lot more material that you can work with. And I think that brings me to the end. This is a fun word that means journey through loss, trials, growth, and maturity, ending where you started in the first place. And that brings me back to a slide that you've seen before. Stay with huge sums of time, and more importantly, plan your success for non-functional requirements, for your security and access policy requirements, and thinking about all the things that you need to support outside of the core functionality of what your users are operating with is something that is incredibly beneficial and can take you a long way. I think I have come dangerously close to my hard stop here, and it looks like someone's coming at me with a hook. So thank you much for everyone who has attended today. I appreciate your time. If there's anything I can answer for you, let me know.